Yeah, we were talking about wire, right? So, to think generally, what is wire means, like think wire as a pipe which is connecting an your syntax tank. Okay, in your home, everyone will have syntax tank. So, the wire nothing but it is a pipe which connects the syntax tank. Okay, so what does that pipe does? It only runs down the water through it. Okay, so like that pipe will not store any water in it. So that's how wire works. Wire means like it represents a physical connection between components, but it cannot store a value on its own. Okay, so same in like what I explained some example, right? Just like that, consider a wire as considered a wire as an physical connection. Like to give another example means wire means considered it as an normal electrical wire which helps to run down a current or pass through a current through it, but it doesn't store any current in it, right? So that is what the like main thing to do. Wire helps to do like it will only pass down a value or an variable through it. Okay, so wire means it represents a physical connection between components, cannot store a value on its own, and wire is also used like assign an statement for combination logic. In our previous class, we were writing that some code, right, in design code, where we are mentioning y is equal to a and b, right, for a AND gate. So that is what called as combinational logic. Combinational logic means it does a logic written in the form which it does not store any memory for it. Okay, like logic which doesn't have any memory. So okay, I will explain it later. Okay, just think at wire as an physical connection between two inputs. Okay, so next think about so like in our code this how our we write wire as wire a comma b out. Okay, assign was doing like this, right? So now just keep that this syntax in your mind. I will explain once I am finished with reg. Okay, so next is main thing to know about Verilog code is reg. Reg means think it as a register. Okay, reg means it is an physical register where we can store an value, like based on that value we can implement a logic. Okay, so what does the actual word reg stands for? So a reg is a variable that can hold a value until a new value is assigned. So mainly we use reg for only input. So in input, in previous class while writing a code, okay, a Verilog code, we were using reg a comma reg b for only input. Why? Because we are using means after once the UUT unit under test case begins, like we are using initial begin, right? Initial begin means begin only once. Okay, it will always allows the user to begin the test bench only once. After that you can end by adding end in the later in the code in the block. So inside that we will give an four options, right? A is equal to 0, b is equal to 0, a is equal to 0, b is equal to 1. Like we are giving its initial conditions. So what does this do? Reg will store a value, like first it stores a is equal to 0, next b is equal to 0. After proceeding with that, it will checks for any other sensitive list. Okay, checks for any other updated value. After that, if, like if a is equal to 0, b is equal to 0, task is done, it will check for is there any other condition do I need to check, like that. So after that, it will check for that value and it updates that value. Okay, until that, what reg will does, it will store that value inside that, right? It will store a is equal to 0, b is equal to 0, until where it will store until it is getting updated by new value, like a is equal to 0, b is equal to 1. Okay, so what does reg do? It stores a value. uh, then what will be the definitions of reg? A reg is a variable that can hold a value until a new value is assigned. Okay, it is behaves like a memory in Verilog simulation. So uh, just keep two things in mind. Reg behave as a memory, whereas wire, it doesn't behave as a memory. Wire is not like, it's not use any memory inside, so it acts as a physical connection. Okay, so for give you like example, think uh, reg as an whiteboard. Okay, whiteboard or blackboard, anything. So if you write a number on a board, okay, then the number is inside that board until you erase it or writes a new one, right? Like that only reg will works. So why I have written here reg is equal to y always at asterisk. Asterisk means it is a sensitive list. Okay, this is what called a sensitive list. Means it creates an like what value needs to be updated next, 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 like that. Okay, if suppose if we have in AND gate, while we are testing a is equal to 0, b is equal to 0 will be our first condition, and next condition we need to check is that a is equal to 0, b is equal to 1. So this asterisk will create the sensitive list. Like we are need to in AND gate we need to test that four inputs, right? Yeah, four inputs. A is equal to 0, b is equal to 0, like that, until a is equal to 1, b is equal to 1. So that value will act will be converted into list that will be stored in here asterisk value, where it is called as sensitive list. Okay, just remember the sensitive list, where it is called and how it can be called. Okay, someone will ask, well, like, what do you know how it creates sensitive list means? Like always at asterisk will create a sensitive list where it shows every value to be checked. Okay, and next, this is the comparison. Okay, see here, this table tells you that how the comparison works, and just note down. Okay, this comparison table is very important. So where does it store value? No. Reg, does it store value? Yes. Where, when will be where used? Where used only when you are assigning a value. Assigning means pass down a value from input to output. Okay, reg will reg be used in assign? No. Why can't a reg used in assign? Because it is a memory element, it cannot be passed down. So reg always will be used in always or initial. Why? To because always and initial, it's need data to be stored inside them. Okay, to perform always and initial block, they need some variables where they can store data inside them. So after proceeding that task, they can update that value. Okay, or change that value. Default value of wire is iz. I will explain about iz in later classes. And reg will be 0. Why? Because if you don't have any value inside a reg means it will be 0, or you can be called as null. There will be no value until you update that value. So wire will be used only for combination logic. Why? Because I did mention that you guys all know about the combination and sequential logic, right? So why wire only uses logic type combination logic? Because wire doesn't have memory, right? So in combination logic, we don't need memory. We just need to pass down a value, right? So that's why wire will only be used the combination logic, and inside right sequential combination both can be used. And assignment style is continuous means like if you assign a is equal to 0 and pass down to output, it will be continuously passing a to that output. Okay, that is why it's called as continuous. Whereas reg procedural means if you suppose if you mention a is equal to 0, b is equal to 0 as initial condition, and next it searches for any other initial next values to be updated in the sensitive list. uh, for example, in your AND gate, the first initial values will be a is equal to 0, b is equal to 0. And next, what does this reg do is it searches for next updating values like a is equal to 0, b is equal to 1 in the sensitive list. That's why it's called as procedural. Means first a is equal to 0, b is equal to 0 procedure is done. Next, a is equal to 0, b is equal to 1 procedure will be undergoing. Okay, so that's why reg works. So this is the main comparison of wire and reg. I hope you guys got clear with wire and reg. Okay, next, if you are like, I just gave you like for wire and reg, think wire as an electric wire and reg as an whiteboard. Okay, keep that in mind. Like it will revise concepts every time. Okay, if that word will like, oh, sir has told like this, whiteboard means reg because it can store value like that. Then you can this concept can be easily remembered. Okay, next we are going with operators. Okay, I hope everyone will be familiar with this operator component concepts. Okay, because it is this concept is somewhat same like in every other programming language. Okay, so what the types of operators we have in Verilog is that we have arithmetic, relational, logic, and bitwise operators. So what does this arithmetic does? Just I will give a simple brief. Okay, I don't go like that much into this concept because it was like it will be everyone will be familiar with these kind of concepts. Okay, so what does this arithmetic do? It perform an mathematical operations like a plus b, a to b, multiplication, addition, subtraction like that. So what does this relation concept does? Relation concepts compare two values to return one or zero. Okay, see I have an example. A is equal to b. If a equals to b means it will return is as true. True means 1 or else false is equal to 0. If x is greater than 5 means it will return as true or else false. Okay, like that this relation operator will work. And in logical operators, we like it returns true or false expressions. Okay, just like logical operators means and double and this is for not operation. Okay, just it sets the opposite. If you set a cell value to 0, then using this exclamatory mark it will set the checks whether cell value is 0 or not, like that. Okay, and bitwise operator, it just like it operates on individual bits of signals. So like this how the bitwise operators will work. A and b means it will operate and operator. This is for XOR operator, and this is for not operator, like that how it works. Okay, okay, now the next section will be always block. Remember, this is the important concept. Okay, always block like after you are knowing like how does initial begin works means you guys need to know about how does this always block works. Okay, so does anyone know anything about this always work block, guys, in the chat? Does anyone know about this always? So okay, uh, I will only explain that always block also. Yeah, someone keep executing runs forever. Yes, yes. Yeah. So until now, we were learned how to use assign statement, right? To like how why we need assign statement in our design code. We are using assign statements, right? Assign statement is mainly used to assign a value. Like for us, we were using something called as assign y is equal to a and b, a and operator b. Why it's used? It is used for and gate, designing a and gate. So like that only we can be used for or not gate also, right? So this is useful for very simple circuits. But if we want to write logic, like if select is zero, uh, but sorry, select means I will explain later. So select means in multiplexer you will have something called as select lines, right? I will come to selector later, but now just remember the word select, okay? If select is zero, choose input a, else choose input b. Okay, until now what we were writing in the design code, we are only assigning a value y with some operations. But now for like building a multiplexer like that, we are going to use a blocks. Like if select will be one, choose this block or else choose that block. Okay, so to use that kind of cases, we are going to use this always block. Okay, like think as if condition is true, do this thing, otherwise do something else. That how this always block works. So like for that kind of decision making circuits, it's like for deciding what to do in what case, we are going to use this always block. So all when will be the always block used? Just remember always block is going to use or come into picture when we have decision making circuits, like we decide whether to follow this step or that step. Okay, so what is an always block? Executes whenever signals in the sensitivity list change. I did mention something about sensitivity list, right? Always at star, that is where sensitivity list is stored. So what is always block? Always block is a block of code that's keep watching certain signals. Okay, what does this do? Like it will track every signal that are moving. Like a is equal to 0, b is equal to 0, what signal going to create for a is equal to 0 and b is equal to 0, and for a is equal to 0, b is equal to 0, what signal is going to be created. Like that it keep track of every signal. So whenever any of those signal changes, the code inside block runs automatically. So just saying that whenever that reg value is updated, okay, I keep say in like in now while explaining reg, I was saying that it search for an updating value in the sensitivity list, right? So whenever that reg value is updated, whenever that reg value its change is tracked from first testing value to second, another value, this block inside that code will run automatically. Okay, so just keep that these lines in mind. Okay, that always block is always active and always ready to execute. Okay, it will be always active regardless of what you are passing. But inside initial begin, it only begins once. Okay, and you can't change in that. But in always block, it will be ready to accept anytime. Okay, for a general example for this always block, like imagine a security guard standing at a gate. Okay, so the guard keeps watching continuously, and whenever someone comes to the gate, the guards react immediately, right? So like that that guard, he doesn't need no one to be told again and again, like keep eye on everyone. Okay, just like that, we don't want always block to say like begin now, begin like that. Okay, so always block, it will be active every time, and it is ready to run automatically every time. Okay, regardless for initial we need to say begin now. Okay, we are using some keyword begin, right? So initial need that begin word to start the task, whereas always doesn't need that. So this is how that basic syntax of always does. Like always at here we are using a asterisk star symbol and begin. Okay, this will create a sensitivity list and no need to list them manually. Okay, and it includes all the input signals in that. Next we are going to think about if else statement. Okay, if else condition logic in Verilog. So if else logic is also similar as in how we use in other programs. Okay, in other programs you are writing like same like this only, like this is the general syntax of if else. If condition begin end executes when true. Okay, else begin execute when false.